Okay, command pattern. This is probably one of the most frequently used pattern as well. So what is a command pattern? A command pattern encapsulates a request in an object. That object is in the form of a command object. And in command pattern, a command object captures everything that is needed to perform that request, maybe sometime later. Okay? So everything is needed is captured in the command object, which includes maybe method name, object which owns the method, and values for the method parameters, and all those things that are needed. What's interesting in command pattern is that it allows a bookkeeping of the request. What that means is that you can collect a set of commands, request, and then you can actually perform a batch, perform the request in a batch. So a typical example that we use for command pattern is like a waiter or front desk. Waiter or front desk person agent. Yeah, waiter collects all the requests, and then those requests, order requests, will be executed in a batch or something. Or there could be a cancellation of that request, or you could undo. Oh yes, that's a cancellation. Things like that. So that's what I meant by bookkeeping, and I'm gonna actually give you an example code in a minute, and you'll have a better understanding. When to use it? When requests need to be executed in a controlled manner, for example, as a batch or at a scheduled time, or based on business logics, business conditions, or undo requests and things like that. Okay. Again, I'm going to come back to this slide after we look into the lab exercises. So participants. So command is an interface. It declares an interface for executing an operation. In fact, this interface contains a single method called the execute. Okay, and then concrete commands that contains the that encapsulate the concrete request. Now it actually receives what is called the receiver. Receiver, you can think of it as like a task executor. Okay, I wish there is a different term, but this is the term that is used in the typical design pattern tutorial. So receiver is the one that actually executes the particular task. Okay, so concrete commands implements that execute method defined in command interface, and internally within this execute method is going to use this receiver to perform the operation. So receiver is the one that actually has the operations to be performed. Invoker, this is the one that actually perform booking of commands. Okay, so you can think of it as like a command manager. You can keep track of what commands are being collected. Okay, and things like that. It has a method that asks the command to carry out request calling execute method. Okay, so again, I'm gonna come back to this slide after we look into the lab exercises. Okay, command pattern. So let's see. The example command pattern we'd like to see is yeah. So let's take a look at the waiter example. So what we want to do in this case is that we want waiter to be able to collect the orders from his or her clients in the restaurant, and then all those orders will be executed as a batch. Okay. All right. So let's take a look at the order command interface. So iOrder, it contains basically a single method called the execute. Okay, now we are going to have a concrete command implementation. So here we are gonna select, we have drink order and food order. So food order, so drink order, it has the reference to actual receiver. So receiver is the one that actually performs the real task. So here I'm going to call it drink preparer receiver. Okay, and basically the execute method that implements the execute abstract method of this order command here is going to use this receiver object. It's going to call the prepare drink method of this receiver. Okay, so the receiver is the one that actually performs the operation. Okay, and this drinker receiver object and drink name will be injected as constructor arguments for this order drink concrete command. And then we have a food concrete command. So here we have receiver is gonna be cook, so we want the cook to cook it. Okay, cook the food. So here we have execute method to be implemented using this receiver object of cook, and it's going to call cook food method. Okay, now let's take a look at the invoker class. So invoke class is probably the one that that might be a little bit confusing here. You can think of invoker is again the manager of commands. This does perform the bookkeeping, as I said. So it has in fact managed the list of commands, in this case as an array list. Okay, but it could actually use whatever structure of its choice. So you could add an order to this list. So basically we are adding an order. You can cancel an order. You can execute all orders. So this is execute a single order, sorry. So you are going to actually execute a single order, and then you can execute all orders as a batch. So here we have execute batch of orders. So in this case, we are going to call execute method of all the commands, and then we're going to actually remove those commands from this list. Okay, so this is what I meant by the bookkeeping of the request or commands. Okay, so we have add order, cancel order. We could have undo order. Okay, so we can probably have an undo order, meaning it probably performs something. Okay, so basically the this invoker does keep track of the commands that have been received. Okay, all right, now if you take a look at the client code. So client code is creating a set of orders. So we create the food order. We create 3 orders, and here we provide receiver. So receiver, we want the so let me just maximize this guy. I want Mary to prepare hamburger, and I want Mary to prepare French fries, and I want Sang to create a pizza, and then we are going to have drink order. So here I'm using drink preparer receiver, so I'm using John, and I want John to create the margarita. Okay, so again, the receiver object could be actually determined during runtime, right? And then we are going to create the invoker object. Okay, and so we're gonna call it waiter. So waiter is basically collecting all these orders. So add order, add order, add order, and so we have, up to this point, it will actually have 4 orders in the list. Okay, and we could actually call the cancel order. So in this case, command C will be canceled. So once it is canceled, then we should have command A, command B, and command D is in the order. So then we're gonna call execute batch of orders, meaning the batch of orders that have been received up to that point will be executed as a batch. Okay, so this is the waiter example. So I think I actually have a waiter. Do I have a waiter before? No, I don't have it. Okay. So if you think about it here, the client, the invoker, if you take a look at the waiter invoker, okay, invoker does not really need to know any concrete command. Okay, so if I want to add other orders to the application, so okay, so waiter. Okay, so if I want to add another, the commands. Suppose I want to uh, the dishwasher. Let me put the leg of the. So I want the dishwasher request to be. Yeah. So basically, yeah. But let's actually look at receiver thing. So this is the one that actually performed the task. Okay. So prepare drink, and the cook is going to the cook food. Okay. So I am going to create dishwasher. Okay. Copy it, and so I'm going to create and dishwasher receiver. So invoker does not know the actual, the task, right? It just deals with the command, right? So it doesn't know, that is in fact the dishwasher receiver. It doesn't know that is the drink preparer receiver. It doesn't know food cook receiver. Okay, so here I have dishwasher receiver. For the okay, so here I'm gonna wash dishes, wash dishes or something like that. Yeah, so maybe it will actually wash the dishes for a particular food. So here I'm gonna actually wash this, something like that. Okay. Yeah, actually there's the food name probably doesn't make any sense, so I'm gonna just remove this food name argument. Okay, so it's gonna just the person is going to just wash. Okay, so now, basically, if I want to perform some kind of the dishwasher receiver, well, let's actually, we can actually have a dishwasher as part of the uh, cook. Yeah, this is the different receiver. So I'm thinking whether I should actually use the, concrete command. Yeah, so for the sake of this, for the demo, I can certainly have the another receiver here, right? So dishwasher receiver, and I'm going to say dishwasher, and basically as part of the execute, I could actually uh, wash the dishes as well, dishwasher, and then wash the dishes. Okay, so the save, and oops, the method wash dishes is undefined for type of dishwasher receiver. I thought I actually defined it, so let's actually save. Oh, okay, good. Yeah. All right, so now we should be able to run the application, and oh, not this one, so I have to run the waiter example, run as, and Java application, and then oops, null point exception, fake invoker. Okay, so okay, so yeah, okay, so maybe this is not actually good. I should actually have another class. Okay, so let's actually do that. Okay, so instead of piggybacking, so we'll actually create another concrete command. So I'm going to have concrete command. So here, dishwasher, wash, concrete command here, and here we are going to, so here it should actually use dishwasher receiver, and we dishwasher receiver, and the food name we don't actually need. Yeah, so we don't need any food, so we are going to remove this guy, food, and food, and why it doesn't like this guy, Dishwasher. Oh, dishwash. Oh, this is dishwasher receiver, isn't it? This is the one that I want to create. Concrete command. And cook. Okay, dishwasher. Okay, and now what we want to do is we want to dishwasher. So let's just remove this guy and dishwasher. Dishwasher. Oh, yeah. Dishwasher, and then we should be able to. Oops, why it doesn't have any dishwasher receiver? Should have wash dishes. Okay, so wash dishes. Okay, so that's good. So we have created the dishwasher concrete command. Now in our client code, okay, we can just add another command. Okay, so we are going to create right here. I'm going to just copy this guy, and and here we are going to have command C2, and we are going to have dishwasher, and we don't need pizza here, I think. Dishwasher receiver, this is one, and person name John. Oh, okay, so I need the constructor. This one has a constructor, so it doesn't like it. Okay, good. So now, client, new order food. Oh, it's not the order food concrete command. It's the dishwasher. Oh, I thought actually I create the concrete command of dishwasher. Dishwash concrete command. Oh, dishwash. Yeah, so this is the one. Yeah, okay. Let me just dishwash concrete command. Okay. All right, that's better. Okay, now we are going to add command C2 as well here. I'm going to just change this guy. Okay. All right, so now we can just execute it. Okay. Control 11. And then you can see wash dishes is actually being printed. So in this case, basically in order to add new command, basically we created the concrete command representing the implementing order command, and then we probably create another receiver, dishwasher receiver class, and then that's pretty much it. You don't have to change any other code, right? The invoker code, the waiter doesn't really have to be changed because it's all working with the abstraction. All right, and I should be able to handle whatever new command that is being added. Right? So again, this is following close, open close principle. So that is the waiter case. Let's take a look at the so let's take a look at the general. So if you see the general, basically we have to have command interface that contains execute method. Then we have a concrete command which implements those things, and it actually receive receiver object. Okay, and then it's using that receiver object and perform operation. So this receiver is the one that actually performed the task. So I would actually call it, this is like a task executor or something like that. And command concrete command B is the same thing. So this is actually implementing I command. It does receive its own I receiver object. Okay. Then we have, in this case, I receiver is we actually have interface, and then we have a receiver 1 and receiver 2. Okay, providing different set of operations. So if you take a look at the UML diagram in this case, okay, so invoker is the one that actually keeps track of all the commands, right? And basically it has one-to-many I command object. So I command object basically contains the execute method, and that will actually have concrete implementation of concrete command A and concrete command B. And internally, this concrete command object has an access to final executor called the I receiver. In this case, we have the interface, which is implemented by receiver 1 and receiver 2. Okay, so these concrete commands will actually use this receiver object to actually perform the final operation. Okay. All right, so that is command general. Now let's take a look at another example, switch statement. Okay, so let's take a look at the before and after. So before is the example where we do not use command pattern. So in this case, we have two devices, toaster device, and we have a light device. Okay, and both of them in fact have the turn on and turn off. Okay, so it is in fact the type of I device. So I device is turn on and turn off, and light is implementing that I device. So it would say light is on, light is off, and toaster is the same deal. It's toaster is on and toaster is off. Okay. Now client, if you take a look at the client, okay, so the bad part of this one is because it's not using command pattern, it doesn't have any way to collect these requests and execute them as a batch. Okay, you basically has to execute kind of immediately. It doesn't really provide any bookkeeping features. Right, so we are going to refactor this code so that we are going to have some kind of bookkeeping operation to be able to be performed. Okay, so here we are going to have the invoker class. So this is the invoker class, is the one, this is a central switchboard. Basically, we want to take all the on and off request, which is a collection of switch command. And again, you can see it does perform the booking operation, add command, remove command, execute a single command, and then execute all commands as a batch. Okay, so this is basically, invoker is providing the bookkeeping and the managing operations. Invoker can execute commands in a batch or use some business conditions or on priority or commands. So internally here, execute commands, it could use whatever business logic, business condition, time of the day, whatever, and based on those things it could actually execute maybe a certain set of commands. Okay, so those are all completely up to this implementation of execute commands. Okay, so now we have and then we have I switch command. So this is basically the interface that has the execute method. Okay, and then you have implementation, concrete implementation of I switch command. One is, in this case, off, basically the turning it off. The other one is turning it on. Okay, so it's turning it on, and it received this I device receiver object, and the I device, this is the receiver object that actually performed the actual turn on and turning on. Okay, and then the toast receiver and light receiver, that is the one that actually performs the light receiver, turn on light and turn on and turn off light. And toaster, you are going to see turn on and turn off toaster. Okay, so in the case of client code, we create the invoker class, which manages all the commands, and then we also create the receiver object. And when you create a command, you pass the receiver object. Okay, And then we add switch on command, and the same thing here, we actually add switch off command. Okay, and then we are executing them as a batch. Okay, so this is basically we can collect all the commands and execute them as a batch. So command pattern is useful when you have a situation where you need to collect a set of requests. Okay, and then you want to actually perform those requests in a batch or in a scheduled fashion, or based on business logics and things like that. Okay, and also, as you can see, you can also add new the request without actually changing this invoker class. Okay, so as I demonstrated a few minutes ago using waiter example, I was able to add dishwasher command. Okay, and the invoker and the rest of the code doesn't really need to be changed at all, right? So again, that's another advantage. Okay, so let's take a look at the homework. So homework is command pattern. So here we are going to actually simulate a travel agent application. So travel agent should be able to, so let's actually take a look at this code. So we want to simulate travel agent using command pattern. So travel agent should be able to receive various kinds of reservation requests: car reservation, hotel reservation, and airline reservation, and things like that. Okay, so for now you're gonna actually deal with just the car and hotel reservation. Okay, so you have to create iReservation interface, which contains execute method. Okay, so that is a command interface. And then you're going to create hotel reservation and car reservation classes that implement this iReservation interface's execute method. Okay, then you have to create the invoker class, which keeps track of these requests. Okay, in the form of commands, right? Which performs the bookkeeping of the reservation request and various schemes of request execution, including batch execution. Okay. So once that works, I want you to add airline reservation class and modify other codes, other codes accordingly. Okay, as I demonstrated, adding another request type is really easy. It's just a matter of adding the airline reservation concrete command class, and add undo previously submitted request to the invoker as well. Okay, all right, so now it's 1 o'clock. I'm going to give you guys about 30 minutes to finish up the exercise and also the homework.